Okay, welcome everyone to the landscape visualization session. First thing, second thing, Thursday morning. We've got 8 presentations going up until lunchtime. The final presentation, the 9th presentation, our presenter from Ghana hasn't turned up, so we're actually going to open that up for a discussion of the future of research directions around visualization. So you're all welcome to attend and participate in that discussion. So we've got 4 presentations this morning, and I'm going to steal a couple of minutes of the first presentation slot, getting an author on that, just to make a couple of announcements. This is co-sponsored by the ISPRS, this particular session on landscape visualization with University of Melbourne. So chairs being myself and Professor Ian Bishop. So we've put this session together, so welcome. So we'll get into the first presentation, and I'm just words about trying to provide a context to this where we see this fitting with modelling and simulation, and hand that over to Alec, who's going to give the remainder of the presentation on the 3D Object Library. So this is the first meeting for the ISPRS Working Group 2.6 on geographical visualization and virtual reality. So we set up a blog website, which is up there. I'm the chair of this working group. We've got Dr. Andy Hudson-Smith from University College London, who's the co-chair for this working group. Jean-Philippe Arabu, JP, if you want to raise your hand, is the research secretary for the working group. So we set up this page, this blog page. There's a whole heap of information there, resources. There's the URL. So this is the first event for our working group. We've also got a video camera, and we're recording all these presentations, and we'll be putting them up with, of course, the presenter's permission. So onto this blog. So if you're not keen to have your presentation put up onto the website, let us know. Otherwise, we'll go ahead and do so. Or you might want to actually review it first. Also to announce, there's also our second event is to be held in Hong Kong next year. There's the 14th International Symposium on Spatial Data Handling, and this is being run by Professor Brian Lees and Professor John Shee, who is the Commission Chair for the overarching commission for this working group that feeds into it. So there's a number of flyers that I've printed out on the table there, so if you're interested in this 14th International Symposium on Spatial Data Handling, on which there will be a visualization component, then pick up the flyer after the presentation or see me. Also, if you'd like to become a member of the working group, give me your business card or JP, and we can get you onto this working group. Okay, so very quickly, visualization. We see visualization as a whole range of models and simulation tools that are out there being presented at this conference and others. But we see visualization as a front end to some of these complex models. And really what we've got here, we've got a bunch of science disciplines doing their modelling, their simulation, creating information, data, knowledge and models. But how can we then engage with community and industry better? Putting pages of equations or box plots doesn't necessarily hit the mark with all audiences. So we feel visualization has a really important part to play in that whole overarching communication, as well as there being underlying kind of mathematics and modelling in creating 3D models and representations. So really we see visualization in the context of modelling and simulation as an innovative medium for communication, bridging the models with our end users, whether they be the community and industry or public policy. Okay, I'm going to hand you over to Philip, who's going to give the remainder of the presentation.
Thanks, Chris. Good morning, everyone. Here is the overview of the presentation. First, I would like to contextualize the visualization with the 3D Object Library project, then research objectives, classification and the structure of the models, available existing libraries, then the Victorian 3D Object Library and Geographical Visualization Portal, and how do we acquisite and construct the 3D models, conclusion of the presentation and future research. Geographic visualization is an extremely powerful tool for better communication and understanding landscape processes, function, and future. And it's being increasingly used in environmental decision making and being used as a common currency between policymakers and as end users. And if you see the image, this is the virtual representation of an existing farm in southwestern of Victoria. And to create this image, we need a very good or probably a high-res GIS layer to place the buildings and the vegetation, good softwares, and of course, a high processing power. But our main concentration today is 3D object library because, as you see, all these objects are coming from this database. So today we are going to say some of the important aspects of the 3D object library. These are the objectives of the presentation. The first objective is to create a systematic 3D object library data collection program and supporting database infrastructure. And second objective is to make them available to people and create and put them on the website to help them to create a 3D landscape, or probably Australian 3D landscape. So if I would like to introduce you with the 3D objects. We try to categorize these 3D objects in following groups like vegetation, animals, build structure, and rural landscape. But, all these models are made by polygons, and as you see that the vegetation is almost a very high polygon models, and you cannot have the high polygonal models every time in your scene, like multiple models, otherwise it will definitely overcome to your processing power. So we try to simulate those models as per the requirement from micro to micro, and they are insect scales, human scales, and landscape scales. So as you see insect scales, as you see here in the image is a virtual representation of a species. It's very good. You can see the texture, reflection, depiction of the branches and leaves, but it's very high polygonal, so you cannot use this type of model, like multiple models in your scene. So this can be used for individual species research or modeling. Then the human scale, where you can see and identify the species from a couple of meters, but you cannot zoom to the leaf level, so you can have like a couple of these type of models in your scene. But when you want to go for the large landscape, you should not concentrate on the single model or the object, but the whole essence of the scene should be there as a whole. And now we try to segregate 3D model as per their construction methods. So there are 3 construction methods. One is image-based 3D functional model and billboard clouds. The first is the image-based, and as you see, it's 1, 2, 4, or 6 polygons. It's very light model, and it's a transparent background. The construction of this type of model is the pasting transparent background image on the plane. And as you see below here, this is an example of this type of model. So for the static purpose, or for the if I try to link this slide with the previous, we can use this type of model in human scale or landscape scale, but we cannot have it in an insect scale, so you cannot zoom it very near. And another problem, as you see here, where the viewer is changing their angle of viewing more than 20%, then they can definitely understand that these are not the 3D models, they are only the 2D images pasted on the projection. The second type of model is 3D function model. They are very high polygonal, as you see, this model is around 900,000 polygon. And basically it's based on a mathematical equation. And as you see below, this is a very simple equation here. And all of these leaves are individual objects. The construction of the leaves are very simple, but when you put these leaves in a specific manner, then it becomes a whole very complex object. And here is the example of the equation. And if you have a x and to xy and y to x, then you can go down together, and somewhere here, around 40 or 50 lines, you will find a very complex structure there. And the third